auto muted and auto off the screen. So welcome. We're waiting for everyone to get here, and then we'll start probably around 10:05, 10:07. I'm just chatting with a couple of the guest speakers. Sarah, they can hear us, right? They just can't participate.
That's correct.
Okay. This is our first time using Microsoft Teams for webinar. So we don't think there's going to be any technological glitches, but just in case.
So far, so good.
We'll see what happens. We were using, I was telling our presenters, we were using another platform for 2 years and was really flawless. And then they had the bright idea to change their software around and really made it unworkable for what we needed it for. So we're switching over to Microsoft Teams for our webinars, which we had been using it for internal meetings, and it seemed to work out really good. And our communications manager assures me it's going to work great for webinars. So lots of pressure on Sarah today. We were just talking to Oliver and Lou about everyone's plans to go back to the office have been interrupted. I gave a prediction of mid-February. Things are going to look a lot better. We'll see what happens. I've been wrong before.
Oh, okay, Lou. Were you able to share something or?
No, that's okay. But I sent it over to Oliver. It's just like basically a little screenshot, okay, so he can present it on my behalf when I start. No problem.
Okay, Oliver, are you able to share your screen now?
I should be able to. Let's see here.
It is 10:01. Let's get it up.
Share window.
If you're just joining us, thank you so much for rejoining us for the AI and Machine Learning series presented by Tech San Diego and sponsored by Cooley. Today, our guest is Flock Freight, and we are just getting things going as you all log in. You are auto muted and off camera for now. And presenting will be Oliver Lum and Lou Saenz, and I will let Kevin Carroll, our executive director, take things from here.
Thanks, Sarah. I'm going to wait till around 10:05 or so. I know folks have just were able to log in at 10 o'clock, so let's get some more folks on, and certainly won't penalize those of you that are coming on time and early. So around 10:05, 10:06 or so, we'll go ahead and get started, formally at least. I see a lot of our friends on the thing. I saw the chair of the Data Science Roundtable, Brandon Quach from Teradata, and I also saw I saw Mario Petrucco, who's with our chair of our Finance Roundtable. So nice to see a very diverse audience for this event. Well, at least the weather's been holding up the past couple of days after our very dreary holiday break, which afforded us no sun whatsoever.
Yeah, that was wet.
Chilly, though, right? I don't
What's
know.
that, Oliver?
As it's been a little chilly, I think.
You know what? I'll take it with the sun. I'll take what we can get in sunny San Diego, which is, for those of you that are watching via YouTube after the event, technology's perfect climate.
Oh yeah, I mean, I went home for those of you who weren't on the call prior to 10. For me is Washington D.C. Back where I grew up for the holidays, and yeah, I'll definitely take San Diego climate, relative to the snow that they were getting. But I even here, I think I saw some engineers on video conference calls bundled up in blankets or wearing sweats the last few days.
Yeah, I think our heaters came on more in the past 2 weeks than it has been in the past year, 2 years or so.
Yeah.
It's always surprising when it kicks on for the first time. Got a couple more minutes, and then we'll get going here.
Kevin, can you confirm you can see what I'm sharing here, which is Flock Freight's?
I can. Yeah, we see the Flock Freight website, the homepage. It looks like, or yeah, it looks like the Flock Freight homepage.
Cool.
And all your passwords just came now. We did have a webinar where someone was, they had a lot of windows open, and one of their windows was their password, one of their password saver programs. And we had to act really quick to tell them to get that stuff off the screen.
Yeah, that's always that, and having chat messages pop up and notifications.
Yeah.
Gotta turn all those off.
Always fun. All right, it's 10:05. Let's go ahead and get started. I know we're going to have some folks that are going to be joining us, but let's not penalize those of you that are early and on time. My name's Kevin Carroll. I'm the executive director, bringing up my reading materials here. My name's Kevin Carroll. I'm the executive director of Tech San Diego. We're a trade association serving small, mid-sized companies here in the San Diego region. Flock Freight is a member of Tech San Diego, for those of you wondering. In fact, just recently. But this series is the AI machine learning series. And there's a couple different reasons why we do this series. First of all, we do want to encourage the region as a data science, AI, machine learning center of excellence. We want people to feel comfortable that they're choosing the region as a career destination in those fields. And it's also, we hear about all these companies in the news, and we really rarely hear about what they actually do and the technology behind it. So again, there's a couple of different audiences and a couple of different goals for the AI machine learning series. The third one is we just want to know more about AI and machine learning and the practical application of that, how it goes in. So normally at this time, my friend from Cooley, Chris Montgomery, would be joining us. Chris could not attend a webinar today, sends his apologies, and will be joining us next time. But I would like to share a few words from Chris, and Chris had written this up. It's funny because Chris starts off, he said, Chris Montgomery is a good friend of Tech San Diego. That is true. He is a good friend of Tech San Diego. Chris heads up the business development and strategy in the Cooley San Diego office. Cooley is proud to sponsor Tech San Diego's machine learning series, and very excited to introduce the Flock Freight team. Flock Freight has been knocking it out of the park. I guess Chris knows them very well. For those of you who don't know Cooley is a 100-year-old full-service law firm with 1,500 attorneys and 17 offices around the world, serving clients in over 90 countries. The San Diego office was established in the mid-90s when they assisted taking Qualcomm public. Cooley represents over 7,000 private high-growth startup clients, from pre-formation teams to some of the most sophisticated companies in the world, including recent unicorns MoonPay and Viori. Others include Snowflake, Instacart, and Zoom. Cooley represents 50% of all the U.S. unicorns on Wall Street. Cooley was ranked this week the #1 most active law firm for VC financing globally and in the U.S. Since 2016, they've completed over 1,500 M&A deals and combined value over $500 billion. The one thing also I wanted to note, just because I know, and I'm glad Chris referred to it, is there's a lot of resources that Cooley has online. And one of the things he wanted to make you aware of is they have a free online resource called Cooley Go. It was designed specifically for entrepreneurs to create efficiency as they build their companies and work with their law firm. So there's a lot of other stuff on there. So go to CooleyGo.com. So that's enough of the Cooley commercial. Thank you for sponsoring. And we hope you, Chris, hope you enjoy today's session on Flock Freight. So let me introduce Flock Freight briefly, and then we're going to get right into the program. So those of you who've been reading a lot about Flock Freight, they're kind of speaking of unicorns, they're one of our region's newest unicorns, which means they have a valuation of over $1 billion. Flock Freight is a technology company that's reducing waste and inefficiency by reinventing the supply chain. They were first to market with advanced algorithms that enable supply chain optimization by pooling shipments Flock Freight creates a new standard of service for shippers, increases revenue for carriers, and eliminates the impact of carbon emissions through shared truckload service. Those of you who've also been reading about Flock Freight in the local papers. We're going to introduce first the CTO of Flock Freight, Lou Saenz. He is the CTO. He leads the product and engineering groups of Flock Freight. He draws on 20 plus years of experience building products and leading highly effective software development teams. Prior to joining Flock Freight, he led product development at 2 SaaS startups from initial traction and growth through successful exit by acquisition. At Taxient, Lou led the development of the company's flagship SaaS product, which the industry recognized as best of breed and hundreds of enterprise customers, including Apple, AutoZone, and Symantec. Previously, Lou was a principal engineer at Oracle, where he developed ContentDB, a large-scale content management platform that handled billions of documents upon each installation. Lou has a BS in computer science and engineering from the California Institute of Technology. A nice intro, and welcome to Lou. Lou, welcome to our series.
Thank you, Kevin. Really appreciate that intro, and thank you everyone here for attending and hearing about what we're working on. We're super excited to talk about this, and we're going to get into some details. Before we start with the presentation, I did want to talk about what we're up to in terms of recruiting. So that's kind of my main job right now, is continuing to build this team. We have a lot to do. We're still inventing, and we're still building, and we need a lot of people to help us do that. So we are out looking far and wide, local in San Diego, but also remote in other parts of the country, to find the best talent to come join our team. We're hiring across the board in our technology organization. So we're hiring in all, not only AI and machine learning and data science, but you can see on the screen here, hopefully, we're hiring in product, we're hiring in engineering, software engineering, throughout the stack. And what I'd like to say is that if you want to work at an engineering and technology culture that has a high bar, that you're really impressed and motivated and learning from your team, this is the place to be. We've really focused on that. We have amazing talent, and Oliver on the line is going to talk a little bit later, and he's one of the folks on our team that just an amazing talent. What I wanted to, rather than just hearing it from me, I wanted to give a few quotes. These are actually from members of our technology team, about what they think about being at the company. So we asked, it's a few different interviews, and you can find all of these on the website. But one of the questions is, why did you decide to join Flock Freight? And one person said, well, one of the reasons I decided to join is that the technical level of the engineering team was so high. Even during the interview process, I could tell that everyone I spoke with was incredibly strong, hardworking, and dedicated to the team. Another person, when asked about, what is it about Flock Freight's technology that gets you excited? He said, well, what gets me excited is the number of features we still need to implement, which makes a huge impact every week. It's not like we work on things for months or years, and then maybe it has some small impact on a small amount of customers. We can work on things for 2 days and have an immediate impact on the company. And then a third person, when asked the same question, said that, well, the driving factor that gets me excited about what I'm doing is our company's mission. And then in terms of technology, what gets me most excited is the fact that I can introduce new technologies whenever I think our current framework is slowing us down. So we're all about innovation, problem solving. If you want challenges, interesting things to work on, if you want to invent stuff and really make an impact on an industry, we're the place to be. So I just wanted to plug us from that standpoint before I introduce Oliver here. So let me do that now. Oliver, he joined Flock Freight as our first research engineer, and he built out the early versions of our optimization technology. Now he's the director of algorithms engineering. He oversees both optimization and data science research at the company. Before Flock Freight, Oliver spent 10 years working on and helping to manage a variety of advanced defense research programs at DARPA, which, if you don't know what DARPA is, it's a pretty incredible organization, Defense Advanced Research Projects Agency. And so he connected with Flock Freight after finishing his PhD in applied math, specializing in network optimization algorithms for efficiently routing vehicles. And Oliver has been a game changer. Like I said, one of the many talented people that we've built, that we've been able to, that have helped us build what we'll talk about a little bit today. So with that, I'd like to transfer over to Oliver, and he's going to take it from here and give a talk on some of the details.
Hey, Lou, right before you turn it over to Oliver, I just wanted to just real quick, and Sarah, you confirm on the questions. I know everyone's muted. We're going to wait till after the presentation, and then Sarah will help us, and myself will help us facilitate the questions. We'll unmute people as they ask questions. So with that said, I apologize, and I'll go back on mute, and we'll keep it going with Oliver.
Thanks, Kevin. Just I guess a clarification on asking questions. Should folks post in the chat to like enter a queue, or just kind of wait until the very end and not take any action until then?
I would ask that people, if there's a question that occurs to you, feel free to add it into the chat. But it will be up to Oliver and Lou's discretion whether they'll answer it in the moment or save it till the end.
I'm presenting my screen here, so I won't be able to see the chat. So I guess Lou, if you want to help, and Sarah, intermediate if there is something that you think is worth interrupting the presentation, maybe a terminology clarification or something to get everyone on the same page. Please feel free to interject. Otherwise, I'll be waiting till the end of the presentation to answer more detailed questions. Does that sound good?
Sounds good.
All right. So yeah, thanks, of course, everyone for joining us today. Of course, Tech San Diego for the opportunity to talk about some of the cool work we're doing at Flock Freight. Lou for the wonderful intro there. Before we hop directly into the slides, I just want to kind of build on Lou's narrative a little bit and say that if there's one thing, I know we have a variety of different folks attending today, whether they be on the university side, the industry side, maybe even some students or prospective job candidates. So I think the one thing that's really common and the goal that I have for this talk is for you to walk away with sort of a pretty deep technical understanding of the problems that we're trying to solve here and why it's maybe a little harder than you might initially think, but that those challenges are really fertile ground for interesting and cool work to be done. And of course, obviously, we'll talk about the technology and how we conceptualize the problem, how we break it down, and some of the algorithms that we use to address certain facets of the problem that we want to highlight. But if there's my hope is that even if the specific low-level details of the technology we don't necessarily have time to cover those in terrible depth. You'll at least fully understand what Flock Freight is trying to do. And so with that, I'll just jump into it. This talk is entitled Relentlessly Eliminating Inefficiency and Waste, which is kind of a tagline taken from our mission statement. And so I'll be talking to you today about how technology enables us to do that. Okay, so at a high level, what's the outline of today's talk? So first, I want to start with some front matter about the company. Who are we? How did we get here? Do some company highlights, that sort of thing. I know, some folks may have done some background research, others may not be, and so I just want to kind of level set and make sure everyone knows what Flock Freight is trying to do conceptually, and then we'll start getting into more specifics. So in the second section of the talk, we'll be covering some industry context. around the problem we're trying to solve. I think there's, in order to fully appreciate the work we're doing requires a little bit of knowledge about how freight works today and how we're trying to revolutionize that. And then finally, we'll get into kind of the meat and potatoes of the talk, which is how do we do it? And even there, we'll start with just a little bit of explanation about how traditional freight brokerages work, what their kind of standard workflow looks like, just very quickly, before moving on to describing the additional technical challenges that are introduced as soon as you add this pooling concept into the mix. And of course, how we grapple with those challenges using a mix of advanced algorithms and technology. So without further ado, I'll jump straight into it. So who are we? What's Flock Freight all about? So Flock Freight is a technology company. We're, a technology, we recently shed the term startup because we're now kind of getting into that, bigger size, more mature kind of phase of the company life cycle. But, until recently, we were a technology startup in the freight shipping and logistics industry. Our mission is to reimagine and reinvent the freight industry to relentlessly eliminate waste and inefficiency. And of course, as with most company mission statements, that's very lofty and very broad, intentionally to allow us the freedom to, branch out in the future. But for now, there's a very specific and targeted way that we try and do this, and that is through ride sharing or pooling. I'll obviously be elaborating on exactly what that means shortly. But that enables us to, for a variety of avenues, create sort of arbitrage opportunities and efficiencies that aren't possible without, ride sharing. Okay, so just a quick company history here. Launched commercially in 2016. 2015 is kind of, maybe Lou remembers those days, but I think it was like 3 employees or less, kind of a thing. So really, things got started in 2016. Spent a couple years building out early versions of, the optimization engine, the web platform, that sort of thing. Really table stakes for setting us up for success before launching our kind of flagship product in January of 2019, which is significant because it was the first time that we offered to shippers at point of purchase all of the benefits of pooling. Prior to that, the customer kind of had a probability of experiencing pooling, but that's not exactly the most compelling value proposition. So it was really in January 2019 with the launch of this new service option that was enabled by shared truckload, where we really started to find product market fit. And since then, have been taking off and growing exponentially from there. Some highlights from last year: getting named to the CNBC Disruptor 50, and of course, closing our most recent round of funding. As Kevin mentioned, cracking that unicorn type valuation. Of course, no presentation would be complete without, of course, thanking our investors. There's some pretty notable names here. Probably the most visible of which is SoftBank, who led our most recent 2 rounds of funding. So really great to see them doubling down, and obviously grateful not just for the capital that they infuse into the business, but also the guidance and autonomy that they've provided us in order to really tackle these set of challenges in a way that we feel is best. Okay, so that's the quick and dirty on Flock Freight and who we are. So now I want to jump into what problem we're trying to solve in a little bit more detail. So the one sentence summary of ride sharing in freight is probably as good as you're going to get for one sentence. But I think in order to really understand the benefits of why in the freight industry in particular, the sharing economy or the ride sharing, this idea of ride sharing is so powerful, requires you to understand how freight would move otherwise. So before Flock Freight, right? There were effectively two options available to shippers of freight. And before I talk about those, I want to kind of first say we're explicitly excluding what's known in the freight industry as the parcel segment of the market. I make this call out because I think a lot of people, when they think freight, they're most familiar with like Amazon packages or UPS packages that arrive at their door, nowadays with the pandemic, maybe on a daily basis. Things that are that small move kind of fundamentally in different ways, multimodal and things like that, is just a different segment of the freight market that, we're not currently addressing. So when I'm talking about the freight industry or the freight market as we see it, it's more bigger items. So palletized freight, manufacturing goods, large appliances or furniture. That's kind of like the category of freight that we tend to be talking about, that would move in the ways that I'll be describing today. So going back to kind of this diagram here, prior to Flock Freight, there were two options. There was you could move your freight truckload, or you could move it less than truckload. And so truckload was essentially point to point. And it's kind of, I think, when people think of how freight works, maybe this is the thing that they think of first, which is you pay a trucker, they show up with their 18-wheeler or what have you, and you load your freight onto the back of their vehicle, and then it just drives directly to the destination, right? So pretty simple and pretty efficient, honestly, in terms of the standpoint of transit times. Like that's about as good as you're going to be able to do. But there are some complications there, and I'll talk about those shortly. In the less than truckload mode of transportation, which was kind of the alternative, you get your shipments moving along a hub and spoke network. So just to make sure it's clear what that means, your goods would still pick up at a pickup location, but instead of traveling straight to the destination, they would arrive at an intermediate hub and be offloaded. And at that hub, the carrier company or the trucking company who's transporting your goods would wait and until they kind of got a mass of shipments that was moving in roughly the same direction. And so they would all be kind of going to the next intermediate hub. Once they had enough of those to fill the back of a truck, then that would justify, moving those things. And so they'd be loaded onto a truck and moved to the next node in this network, right? This next hub. And it would hopscotch around, kind of waiting and being offloaded and reloaded at each of these intermediate locations until it reached a hub that was reasonably close to its final destination. And then there's, some last mile delivery that would happen, right? And, of course, this was more well-suited for shipments that are smaller, where maybe it doesn't make sense to pay for the entire back of a truck. And where you have to really do this aggregation to reap kind of economies of scale. So those were the two options. What were the drawbacks of these? Well, each time in the freight industry, there's this notion of a touch. So a touch is a load or an unload of your goods. So each time your freight is touched, there's the possibility for damage and loss. And I was actually very, not being a freight industry veteran until I came to Flock Freight, I was very surprised. This possibility is not, negligible or de minimis at all. It's really, I think, over an order of magnitude worse, moving your goods via this hub and spoke network because of these intermediate stops and how many more touches that your freight is being exposed to than if you move it kind of point to point by a truckload. So that possibility of damage and loss is really significant, not just because your goods can arrive damaged or lost, but also, it has insurance implications and, other kind of negative externalities. The other thing that's really notable about moving goods by a standard less than truckload over this hub and spoke network is the potential for delays. So I already kind of alluded to this with at each of the intermediate hubs, there being this need to wait for other shipments to kind of be aggregated before it justifies them moving. And those delays not only inflate the transit time significantly, but they also introduce tremendous error bars around when your stuff is going to arrive. So for example, when I actually moved from the East Coast to the West Coast, when I started this job, I moved, a lot of my, with a moving company, essentially, a lot of my stuff in my apartment, right? And I believe the transit time estimate was something like anywhere from 10 to 25 business days. And it turned out to be like 21 or 22. So, there's, if you really need to know with better precision when your stuff is going to arrive, well, moving it via LTL, over hub and spoke has some severe drawbacks. There's sort of difficulties or frictions for the customer as well that aren't even really associated with how the freight moves that are worth calling out here. So LTL carriers have kind of a forget what they call it when it's not a monopoly, but there's a very small number of them, so they can essentially price collude in a lot of instances. So there's a complicated pricing structure. I like to call it the Black Friday pricing structure, where everything is discounted like 50 or 60% or more. So it's really hard to tell if you're getting a good deal because everything's opaque and you don't know if the next guy is getting 75% off versus your 60% off or what have you. So there's a lot of opacity in that sense. And of course, there's priority for smaller shipments moving along these networks. In fact, for many carriers, there are caps on the size of the shipment. So if your shipment's bigger than a certain size, you might not even be eligible, even if you were willing to put up with a lot of these other cons. So as a result, there are many cases where shipments that are significantly smaller than filling up the back of a truck end up moving truckload anyways, because the shippers aren't able to tolerate these pretty severe limitations or drawbacks. If you have fragile goods, that can cause you to want to buy truckload. If you need it to arrive more quickly or with greater precision, that can cause you to buy truckload, even if you don't. The cost implications are pretty severe. Of course, that leads to some challenges with the truckload on the truckload side. So if you have enough freight to fill the back of a truck, then that's great. That's pretty efficient. But in these cases, these non-ideal cases where you're moving with empty space, we like to say shipping air, so to speak, then it creates a staggering amount of waste, and that obviously has sort of environmental drawbacks, right? Not to mention the cost implications, which I've kind of stressed several times. If you could share the back of that truck and share the cost with other shippers who are moving shipments in a similar direction, then obviously that has clear benefits in terms of reducing your costs. So of course that leads to this solution that we've invented, which is a new mode of transportation called a shared truckload. So as is probably obvious, a shared truckload is ideal for kind of the middle cases. So if you have really small things or things that already basically fill the back of a truck, shared truckload doesn't offer quite as much value prop. But the vast majority of freight kind of lies within this 8 to 44 linear feet bucket, and there are significant benefits for moving shipments in that category via shared truckload. Already mentioned LTL shipments that aren't eligible for LTL, or I guess small shipments that aren't eligible for LTL fall into this bucket, as well as truckload shipments, or I should say that with scare quotes, truckload shipments that don't really fill an entire truck fall into this category as well. The way that this works is we use algorithms to essentially determine the routes beforehand a priori. So rather than doing aggregation at physical locations in a hub and spoke network, we just use our technology to determine how to combine these shipments into efficient routes. And then that kind of forms like a synthetic truckload to truckers, where they will service or pick up the shipments in a certain order, and then drive directly to the destinations and offload them. For us, in order to preserve that sort of reduced risk of damage or loss, we always service shipments in last in, first out order, because that means your shipment won't have to be unloaded in order to be for other customers essentially who are sharing in the ride to have their goods unloaded first. And so I mentioned this kind of with the company highlights, but Flock Direct is kind of the service option that is available to customers at point of purchase, which guarantees the benefits of shared truckload service. So what that means is that the company takes on the risk, and if we're not able to pool your shipment, then we will still move it via a truckload kind of transport mode, so that all of these benefits, the customer will experience, and really Flock Freight ends up taking the monetary hit there. So just to recap, benefits of shared truckload or Flock Direct: less risk of damage because of the one-touch guarantee, reduced cost in the cases where you're sharing space with other shippers, then you're sharing the cost, and faster transit times because there's no stopping at these intermediate hubs waiting for aggregation. I should also mention, a big driver of what brought a lot of us to the company was sort of the green aspect of Flock Freight's mission. So, very proud to be able to say that we're achieving 100% carbon emissions reductions. You might say, well, how do you do 100% carbon emission reductions? I mean, there are still trucks going over the road. So obviously, by pooling, we're able to reduce the number of vehicles moving across the road necessary to service the shipments. And for the remainder of Flock Direct shipments, we at no additional cost to our customers, because we believe so much in the ability of pooling to be effective and reduce that carbon footprint. We also purchase carbon offsets for the remainder of that. To date, we've pooled over 70,000 shipments moving over the road, which we estimate has resulted in 22 million pounds of CO2 avoided or eliminated. Okay, so hopefully, at a high level now, you kind of understand enough about the freight industry, how things are done today, the inefficiencies that are incurred by doing things the old way, and what Flock Freight is trying to do to move things in a productive direction. So how do we do it? Okay, the first thing we need to talk about is freight brokerages and how a traditional freight brokerage works, because the workflows and sort of processes underlying Flock Freight most closely philosophically resemble a freight brokerage. So in the old world, there would be these companies called freight brokerages. They are essentially a middleman play, where the service they're providing is helping you navigate sort of a complex a carrier market. So just a quick vignette here on the left. You start with a customer who in this case is a shipper. You can think of it either a small, medium, or large size business who wants to ship a bunch of goods from point A to point B. They would reach out to or get in touch with somehow a freight brokerage, a customer sales representative from a freight brokerage, and negotiate a price with a member of the sales team. And then assuming that they found that price agreeable, they would commit the shipment and agree to move it with the freight brokerage. Then the freight brokerage would turn around and provide that shipment to their carrier sales team, who would have established relationships with a bunch of carriers. So again, reminder: a carrier is a trucking company. they actually own and operate the vehicles that move these shipments across the road. And it's worth noting here that the reason it's sort of beneficial for customers to interact through a freight brokerage with these carrier companies rather than just approaching the carriers themselves is twofold. One is freight brokerages do consistent volumes with carrier companies, so they're often able to negotiate better rates than an individual customer might be able to. And then second of all, the carrier market is, especially on the truckload side, very decentralized and fractionated. So there are thousands, whereas on the LTL side, I mentioned before, there are like maybe a dozen big players in that space. There are thousands of truckload carriers ranging in size from, mom and pop type operations with less than 10 vehicles, all the way up to, these massive companies with operating well over 10,000 vehicles. And so, if it happens that your shipment is actually a really amazing fit for a carrier that, is more of one of those mom and pop type operations, well, that's sort of, it's unreasonable for, a business whose main, concern is not shipping to have to continue to maintain and find all the, establish all those relationships with various carriers and try and do the dance and find that optimal carrier, right? So the freight brokerage would do all of that for you, and they would take care of the negotiations on the other side. And the whole play for the freight brokerage is hopefully the price they arrived at with the customer to move the shipment is higher than the price that they agree to move it with the carrier. And so that's their margin, right? Customer says, I'll move it with you for $1,000. They find, brokerage finds a carrier willing to move it for $750. That's $250 of margin for the brokerage. So that's, in a nutshell, how freight brokerage works. Very straightforward, pretty simple. And there are certainly attempts to streamline these traditional workflows. I think if you hear a lot about what I think other people think of as competitors to Flock Freight, other freight tech type companies, they're really working at addressing and points of friction within kind of these standard workflows. Whereas, Flock Freight is doing something fundamentally different, where we're actually trying to change how the shipments move. But that comes with quite a bit of additional complexity. And the reason, I guess, if there's one thing to call out here, in terms of why introducing pooling makes things so much harder to deal with, it's because of the optionality of pooling, right? So now at point of purchase, we don't know exactly how the shipment is going to move. And that, in a nutshell, is what causes a whole ton of new questions, interesting questions that we have to answer, before being able to hand off a shipment or a pool to a carrier. So, just to cover some of that complexity, we have to determine how we should adjust pricing, both to the customer and to the carrier, given the possibility of pooling. If a shipment is has a high probability of pooling, can we then turn around and provide more competitive rates to customers? And is it worth doing so, right? What is the price elasticity of those customers? And will we win enough, more freight to justify providing that discount? Similarly, on the carrier side of things, what is a fair rate to execute a pool? In the industry, there's kind of well-established, standardized ways of thinking about the cost to move an individual shipment. But Flock Freight is the only pooling game in town, right? So we kind of invented this concept, and all these carriers, since they're kind of unfamiliar with it, and there's no standard for how to think about what a fair rate is to execute a pool, they all think about this slightly differently. In fact, I shouldn't even say slightly. They all think about it occasionally wildly differently. And that leads to much more complex kind of negotiations and reasoning about what the cost to fulfill a pool will be, and how to locate that one carrier who, thinks that it's not that much more difficult than executing an individual shipment, and willing to, reflect that in their rates. Of course, how should we move the freight is an important question that we have to answer. It's kind of the first order question we have to answer. There's not just one way to pool a shipment. Many times there could be 100 different ways of combining a particular shipment into pools that looks profitable. And it's not always the best decision to just pick the most profitable of those. So how do we reason about these sort of interactions between shipments? Because obviously the way you decide to pool shipment A impacts the way that shipment B might move, right? Maybe you can pool it with shipment A, maybe you can move it alone, maybe shipment B can move with shipment C, and that would preclude a different pool with shipment A from moving. So there's sort of this global optimization problem that we have to solve across all of our shipments. And finally, when do we decide? So, that might not immediately kind of appear as an obvious question we have to wrestle with, but a lot of these shipments appear with significant amounts of lead time. So, if you have a shipment that doesn't need to pick up or even can't pick up for 5 days, say, and maybe it has 2 days of flexibility to pick up, when do we commit to, picking an option, picking a pool, or selecting to moving that shipment alone? Because if we wait longer, maybe we'll book another shipment that pools really well with it, and we might have, committed ourselves out of being able to execute a really awesome pool. On the other hand, if we wait too long, then we have to pay a lot of money for kind of the urgency and last minute kind of service to get a truck in there fast. And evolving markets and rates could significantly drive up the cost to fulfill even the individual shipment. So there's a dance we have to play in terms of what the ideal time to even make the call is. Okay, so that's a lot of complexity to have to grapple with. How do we take now this challenge and decompose it and start to inject technology into the mix in order to address these challenges? So I'm going to focus on kind of the core problems that I think are pretty unique to Flock Freight and its business model relative to other freight tech companies, and talk in the most depth about these kinds of problems. They're the ones that differentiate us the most. But at the end, I'll give a quick nod to, there's all of the standard problems that, other freight brokerages, other freight tech companies have to deal with. We also have to deal with. So at the very end, I'll just kind of quickly go over those. But starting with the kind of more interesting and unique stuff, I'll start with the pickup and delivery problem. So it should strike you as no surprise that at the heart of Flock Freight lies this vehicle routing problem. And as Lou mentioned, that's kind of where my background is deepest, where my graduate research was in, and some of my professional experiences, and certainly the work that I brought to the table early days at Flock Freight. So the pickup and delivery problem is a classical vehicle routing problem from network optimization. And if you haven't heard of the vehicle routing problem, no worries. Obviously, that's a bit esoteric, but I think a lot of you probably will have heard of the traveling salesman problem, which is kind of the simplest version of the vehicle routing problem that exists. The vehicle routing problem is just a more general name for if you want to start layering in more constraints, more complexity than simply, the salesman has to visit all of the nodes in the network at least once. So, common additional complexities include kind of real world concerns like time windows and things like this, right? And of course, if you have heard of the traveling salesman problem, you probably heard about it in the context of how hard it is to solve. Of course, if you're really deep into that literature, you might know that the traveling salesman problem is luckily simple enough that even though it's NP hard or NP complete. As it scales, it gets really hard to deal with. Empirically, methods have kind of matured enough over time to where that it's effectively solved, where you can solve problems with almost 1 million different nodes pretty quickly and exactly. However, the same is not true for vehicle routing problems, and especially not for vehicle routing problems with industrial complexity. So like in a lot of fields, especially ones where math modeling is kind of, key, academics kind of focus on one level of complexity that, is great for proving theorems and writing papers. But when you hit the real world, there's a lot of additional dirtiness that you have to wrangle with. And, our pickup and delivery problem is certainly no exception. So there's the standard, of course, defining constraints called the pickup and delivery constraints. So instead of every shipment being represented as a single node on a graph, it has a start and end point that need to be traversed in a certain order in order to service that shipment. We have multiple time windows per stop, which is pretty unusual. In the literature, there tends to be one contiguous time window, or many problems or many articles in the literature will even completely omit treatment of time windows at all. But in the real world, you've got, this stop or this location is open from 9 to 5, Monday to Friday. Maybe it's got reduced hours on the weekends. And all of that has to be taken into account when you're thinking about route feasibility. Can I actually service these shipments together? Already talked pretty extensively about why we regard last in, first out as a loading constraint here to preserve the one-touch, property, but that gets played out, in solving this problem. We have to consider that. Obviously, vehicle capacities are a concern. So there's a such a way to fit them on the vehicle. And then there's also some interesting complexity around the cost function, right? So this is an optimization problem. And the first, obviously, thing you have to ask yourself with any optimization problem is, what is the objective function? What am I optimizing for? In our case, that cost function that we're trying to minimize depends on the first shipment in the route, because that determines where the trucker will start and stop. And costs in the freight industry reflect kind of the desirability of kind of ending up in a region where there will be an easy possibility of reloading. So, by market, there are different rates for a route depending on where it starts and ends. That's also something that's pretty non-standard in the literature that we have to worry about. Obviously, the cost function depends on trailer utilization. So the more full, a truck is, sometimes the more you'll have to pay. There are certainly limits to that, but that's kind of a nonlinear relationship. And just the scale of it, in the literature, it tends to be anywhere from, tens of shipments if you're using an exact method, or hundreds of shipments if you're using heuristic methods. But we have to deal with many thousands of shipments, over the course of a short period of time. And so we obviously have to make sure that our algorithms can grapple with that, obviously in exchange for some degree of optimality. Clearly, it's an online problem. So as we're booking shipments every day, right, new ones are entering the system, some are leaving or getting picked up. So the problem changes literally on a minute-to-minute basis, and we have to keep everything kind of in sync. So, it's obviously a very detailed and rich optimization problem to solve. So in terms of how we solve it, well, we kind of have to throw the kitchen sink at this. Not only do we use, I think, what I would call standard meta heuristics from the vehicle routing literature to solve that underlying pickup and delivery problem, but we also have to grapple with that scale somehow, and the sort of curse of dimensionality of these combinatorial optimization problems. And the way that we decide to do that, obviously I can't get into too much detail, but it's with a combination of clustering and sampling type approaches to reduce the complexity without sacrificing too much optimality. And the way we get insight into that is by doing simulations and testing and convincing ourselves that the methods, the specific methods we've chosen, the order and constraints we've decided to enforce are not severely degrading our ability to find good routes quickly. Before I move on to the next problem, I think I heard someone come off mute. Was there something that I should address?
Just really quickly, a couple questions came in. The average lead time per shipment and the volume of shipments you are managing on a daily basis.
Yeah, so what I'm doing is while Oliver's talking, I'm kind of watching the questions and I'm going to try to answer them in the chat, and then maybe after the talk we can go into some more detail there, if that makes sense.
Perfect.
Cool.
Thank you.
All right. So the second problem that I'm going to be talking about is recommending the optimal fulfillment strategy. So, at the end of solving that pickup and delivery problem, we've got now a bunch of routes. I mean, tens of thousands, hundreds of thousands, a day kind of live at any given point in time. So, how do we pick amongst those? Because, they obviously overlap. We can't do all the pooling opportunities. There's 100 ways to pool shipment A. We only have one copy of shipment A, right? So how do we pick amongst them and come up with this sort of one plan that we want to try and execute? And to kind of motivate this a little bit more, I want to refer to a toy example kind of on the right side of this slide here. So this was a problem that we faced very early on in the company's history. I think it might have been late 2018, early 2019, where basically we had come up with a prototype solution for the pickup and delivery problem. So we had this list of pooling opportunities, but we didn't really do anything more with them. We just displayed them in a UI and let our operations team, our carrier sales team, look at them and sort them and interact with them, right? So they could essentially manually pick which ones they wanted to do. And as any, I think, reasonable person tasked with executing pools as profitably as possible would do, they just kind of sorted by profitability, and then they would go down the list and say, okay, I want to try and do this one, and if I can do it, then that obviously eliminates some possibilities further on down the list, and the software would kind of auto adjust to that, right? And then only surface the remaining ones, and they'd again sort by profitability, go down the list until they pretty much pooled as much as they could and moved the rest of the stuff unpooled. The problem is that leads to very non-optimal solutions. That kind of greedy heuristic doesn't end up getting you moving your shipments as efficiently as possible. And to see why, you can see here, if you took that strategy, the circles here represent shipments and the boxes represent pools. So the second pool here, would pop up first in your sort, and you try and execute it, and maybe you'd be successful, but that would prevent you from doing the first and the third pool, which don't overlap, and together would net you more of an arbitrage opportunity. And so, being able to identify, hey, there's actually a better way to execute these shipments, was sort of a core question that the business had. I think with 3 shipments, it's easy to look at this and say, oh, I can just eyeball that, right? But with 10,000 10,000 pools or 100,000 pools, certainly a single person and even a team of people would have a very, very difficult time making any sense of what the best overall strategy is. So that at its core was the problem that we were trying to solve. And just like in the pickup and delivery problem, there were all sorts of interesting complexities that we had to tackle. One of which was kind of execution and coordination risk, had to be baked a little bit into the optimization. So as a very simple example, let's say you were trying to pool 4 shipments together. That's 8 different locations. And let's say 6 of those had, appointment scheduling requirements. Maybe there's only one way to make, the route timing feasible. You have to get exactly this appointment itinerary and have everything line up. But, it's unlikely that you're going to be able to do that. And maybe you're already against the wire and you know that some of these facilities are hard to work with or hard to reschedule, right? Is it really worth trying to execute that pool for $2 additional in estimated arbitrage versus these much easier pools to execute that have a higher likelihood of succeeding and potentially even being negotiated below cost, right? So these kinds of considerations started to enter the mix in addition to kind of the core optimization. Obviously, this was also a streaming problem. So as these shipments were being fulfilled, we have to keep everything up to date. Not only as shipments are being moved, but also in response to new information, adjustments to when shipments are ready, last minute changes in dates, things like this, and it had to be responsive from users. So this is another thing I want to highlight, and it's actually pretty standard in sort of logistics firms, even consulting firms that try and do these routing algorithms for like FedEx and UPS. There always has to be this sort of, in a good system, I should say, there always has to be this feedback loop from users because at the end of the day, there's going to be some weird cases that your model isn't going to be able to accommodate directly, where you want to be able to adjust or optimize around feedback in sort of this collaborative way with users. I should also mention that there's sort of 2 kinds of versions of this problem. One where we're really recommending an optimal fulfillment strategy for our internal resource constrained, bandwidth constrained team, and also a version for, when we surface these pools broadly and directly to our carriers. Some of these things, matter more or less to the various audiences, and we have to, make informed decisions about when to enforce which of these constraints versus when it's okay to take on maybe some additional risk because the consequences of not executing are lower. There's also plenty of times when things don't go exactly according to plan. So maybe you booked one of these pools, the truck moved and it picked up shipment A, but we now got to the pickup location of shipment B, and lo and behold, shipper isn't ready. Something went wrong. Truck breaks down, right? So now you have to rescue shipments B and C, and all in the context of sort of these knock-on effects and how it impacts how you fulfill other shipments. So definitely lots of interesting complexity to wrestle with. And high level, we use a mix of constraint programming and mixed integer programming to deal with all of those, and it results essentially in a suggested fulfillment plan here, which you can see this is the UI that our internal staff interacts with, where they can see at the end of the day, here's just the list of recommended pools. Everything else, can move unpooled because that's the best way to fulfill it at the moment. And they can review the routes, and socialize them with our carrier network to get them moved. Okay, the third problem I want to talk about here is around predicting pooling outcomes. The first 2 problems I talked about are really kind of table stakes, right? If you want to be able to do this route optimization and scale, you really have to be able to solve those problems in any incarnation of a business that's trying to do that. This is a problem, though, that is pretty interesting in that it was one of these that was born out of kind of an organic phenomena that we started to observe happening. So before I talk about kind of what that problem was, basically what I'm talking about is we wanted to, at order time, let's say, forecast how likely is a shipment going to end up being found in a pool, any pool? How likely is it to be recommended in an optimal fulfillment strategy at any point in time? And of course, how likely is it to then actually be converted and for us to decide to move the shipment in that way, right? And the reason that this intelligence is pretty important has to do with this scenario. So in about summer of 2020, we were encountering a lot of this happening where, we might get a shipment that was ordered on Monday and ready for pickup on Friday, right? The solver technology that we were talking about before, solving the pickup and delivery problem, didn't find any pools for the shipment throughout Monday because we didn't actually have any other shipment that paired well with it in the system yet, right? So Tuesday, they say, oh, we didn't find anything, and I found this carrier that's willing to move this shipment unpooled individually for a pretty good rate. Like I can get a little bit of profit from it, so we'll avoid any losses. Looks pretty good to me. I'm going to book it, right? And if you remember from our sketch of the traditional freight brokerage, that's like how traditional freight carrier sales teams are trained to work. They want to find and cover these shipments as quickly as possible at rates that are low for fulfilling that individual shipment. So from their perspective, it made a ton of sense to do this. The problem, of course, is that because in our business, how one shipment moves impacts the way every other shipment moves, potentially. Then on Wednesday, we'd have that golden other shipment that pairs really well with the one that was ordered on Monday. Lo and behold, it's ready for pickup also on Friday. And so our solver technology identifies it and it gets recommended in the optimal fulfillment strategy. Problem is now when our carrier sales team goes to review whether or not we can pool this, they realize, we committed it to this individual carrier, and they can call them up and maybe try and add that shipment on, but in many cases, that carrier might not be interested. Maybe they themselves have made other plans for the remainder of their truck, trying to be kind of like a one-man pooling operation kind of a thing. And just for whatever reason, they might not want to take that. In fact, it's pretty common that one carrier will not want to add on for various reasons. Maybe their vehicle can't even hold the remainder of the freight. So that would lead to us being unable to pool the other shipment, right? The shipment that was ordered, either of these shipments, I should say. There was another option, which was we could call off the initial cover, but that kind of was sort of bad business practice, and we'd be reneging on contracts and whatnot and signed documents. So we made a conscious and strategic decision not to make it a habit of just calling off commitments that we had made prior. So what we really wanted was a way to know exactly when in this workflow we should feel comfortable, making this call of, is it going to pool eventually or not? And that's really what, this pooling probability business is all about. And so this was kind of our first major foray into, machine learning, data science. We built a set of models to essentially help us determine what that probability to pool was at order time. And if a shipment had a low probability to pool, okay, we wouldn't intervene too much. It's okay for you to find that carrier and move it unpooled pretty early on, kind of in the timeline that that shipment is live. However, if it was a very high probability to pool a shipment, okay, well now we're gonna hold on to it. You know, you can negotiate with carriers, but you can't commit it to anyone unpooled for quite a while, because we're pretty confident that you know, either we already have that order that pairs well with it, or it's going to come in at some point between now and the pickup deadline. And so we implemented this, you know, operationalized it, you know, using a hold and release type mechanism to alter the behavior of our team and kind of give them that intel of when, you know, to make or how to make kind of good decisions around when to commit. So just in case it wasn't clear, here's now the modified vignette with this system in mind, where the shipment's ordered on Monday. The pool is found now on Wednesday without the Tuesday cover. And so Thursday, when that shipment is, when that pool is found, now we're actually able to execute on it. I think I heard someone come off mute, so I'll pause here.
No, go for it, Oliver.
Okay. All right. The last problem I want to talk about very briefly is rate setting in a two-sided freight marketplace. So obviously there's some sensitivity here. This is a pretty core, you know, to the business and specifics of how we deal things. So I won't talk too much in low-level detail about how we try and solve this problem, but just to, you know, make sure I can touch on all the complexities of the problem that we're trying to solve. You know, we're a two-sided marketplace, right? On the one hand, we've got shippers on the demand side and these truckers on the supply side. And, you know, presenting prices to them varies based on a lot of different factors and sort of a distinct set of factors, right? So for shippers, okay, there's the obvious things like load characteristics, how big is the shipment, how much does it weigh, et cetera. There's also the service option, right? So I mentioned Flock Direct is our flagship product. It's this elevated level of service. So we have to produce prices for Flock Direct where we guarantee kind of the benefits of pooling, as well as, you know, for standard service where if we can't pool your shipment, it's going to move kind of traditional ways. We obviously have to take into account how likely something is to pool, because if it's very likely to pool, then we can offer you a better rate. We have to think about pickup flexibility. So one thing I haven't touched on is that, you know, unlike in a traditional freight brokerage, we value a customer saying, yeah, you know, as long as a shipment gets here by X date, you can pick it up Monday, Tuesday, and Wednesday, because that additional, you know, flexibility gives us more opportunities to pool it, and it's more likely that there's another shipment that might line up with it. So taking into account, you know, the timing flexibility on the part of the customer in exchange for discounts. For carriers, you know, it's obviously load type matters, whether we're talking about an individual shipment or a pool. For individual shipments, it's more straightforward. The main thing we're curious about is evolutions in spot rates and markets, you know, where truckers want to be and where they want to end up. And then carrier preferences obviously starts to come into the equation when you talk about pools. So some carriers, you know, especially like in the last few weeks, they want to end up home for the holidays. So they might be willing to do some pretty weird routes because they want to end up at home base or service shipments in an unintuitive order, right? So they might give you a better rate on something that ordinarily might not appear to be, you know, the most efficient. There's time sensitivity that we have to take into account. So last minute rate adjustments, I already mentioned that was a motivating factor for not just holding everything up until the last minute to try and pool it. There's an element of negotiations that's just inherent to the industry, right? It's sort of accepted practice that you're going to go back and forth with a carrier to arrive at a standard rate. And so, you know, an initial bid is just that. It's an initial bid. And so, you know, you really want to be able to discover the price floor in a lot of cases. And then execution risk and difficulty, opportunity cost relative to the optimal execution plan. You know, if we're going to let a carrier do something that we don't strictly think is the most optimal for us as a business, well, maybe it's okay if they're willing to give us such a good rate that it would become optimal. They're willing to do it way below our cost estimates. So, how do we adjust pricing for non-optimal permutations or non-optimal pools, and still get those out in front of carriers who might be willing to fulfill those non-intuitive options. And this is just kind of a quick visualization of how that plays out in our UI. So in the top half here, you can see to the customer, you've got across the top service level, and then on the bottom half of that, flexibility, and that turns out to play out in terms of pricing, right? Flock Direct is significantly more expensive than standard, but you can see this transit time, right? Difference, it's less than half of the standard estimate. Flexibility is also results for this shipment in a small discount. And similarly, for carriers, the problem is, okay, it's not just a small matrix of options you have. You could have hundreds of eligible loads that are, ready for pickup near you, especially since there's different permutations, different ways you can kind of service the shipments. And so for each of those, we have to figure out what's the kind of buy it now price, what's the bidding price, starting bidding price, and all of that. So that's about as much as I'm going to cover for the rate setting problem. And I'll just close the talk by, again, touching on kind of the additional challenges we have to face, but that lots of other companies also have to face. And these are more standard ones. So as a two-sided marketplace, we have to wrestle with customer accounts and carrier accounts, what their lifetime value is, estimating that, segmenting them to figure out, what the best course of action is in terms of keeping accounts alive and growing, retaining customers, and preventing churn. And it's one of the I guess interesting wrinkles that I definitely didn't think about until I came here was the timescales upon which churn happens in a highly seasonal business. So you could imagine there's a shipper that pretty much only ships in, I don't know, March, because that's when they're shipping produce, and that's when their produce is in season. So you might not know for that shipper whether you've churned until next March. But for other shippers who ship more frequently, you have to kind of keep tabs, and you'll be able to react more quickly. Of course, at the bottom here, you've got carrier capacity matching. So just even knowing telemetry of vehicles, there's 10 carriers with empty trucks in or near this metropolitan area. Here's the 100 loads that we have, or pool opportunities, individual shipments, and being able to proactively reach out and say, hey, we got these opportunities for you. They pick up at this date, so that we get more shots on goal, more opportunities to collect better rates from our carrier base. And finally, the kind of holy grail for a lot of freight companies, market rate forecasting. So, most of the major data providers in this space tend to just produce estimates based on trailing historical averages. So if you could somehow get ahead of this, see what the rates how they'll behave, kind of along the same time scales as the lead times that your shipments are booked with, you can anticipate when it might be more or less difficult to fulfill shipments and use that to adjust, when you make decisions about, locating a carrier, and just get ahead of things in general. So with that, I think that concludes the presentation. Hopefully, like I said at the top of the talk, if nothing else, I've thrown a dizzying amount of complexity at you, and regardless of what your individual background is, whether it be in software engineering or one of these research domains, data science, machine learning, optimization, applied math, there's something here that you could see yourself working on. And with that, I'll pause for questions.
Oliver, first of all, Thank you very much. Big, you may not be able to hear it, but I'm giving you a clap there. I think what was nice about the presentation is we got a glimpse of why. And typically on some of these presentations, we get a look at the technology, and it doesn't really go into, why those technologies, the problems behind that, and kind of the problems they're solving. So a big thank you. Lou has been answering some of the questions in the chat. Lou, do you want to recap any of those questions, or should we just, Sarah, maybe you can help us kind of open this up to questions? We do have a couple of minutes, 11:19. We're scheduled to 11:30.
Well, if I could, I would love to. I don't know if we'll have time to recap all of them, but there's one question that just came in that I thought I'll answer here verbally, and it's actually a nice question because it lets me tell a little bit of a cool story that can sum up maybe some of what we're actually doing from a standpoint of impact to our customers, and in particular to our carriers. So the question was, is there a best or favorite feature that the carriers love while using our application, right? So I mean, there's lots, right? I mean, carriers really they're looking, they get paid, right? Carriers are hauling our country's freight, and I mean, especially during pandemic times and when things are so tight, carriers are like the lifeblood of the GDP in some ways, right? In many ways, and we talk a lot about our environmental impact, right? We're trying to reduce and eliminate waste and inefficiency, pack more shipments onto a vehicle, right? So that's a great improvement for the planet. But we actually, just thinking about the carriers, the people driving these trucks and hauling freight, one of the big benefits is earning more, right? So by having more revenue on board, it's actually a win. It's a great business model because it's a win-win-win. The shippers win because, as Oliver mentioned in the talk, there's all these problems that have to do with hub and spoke networks that go away. So we can essentially give them an upgraded level of service for, in many cases, a lower price. So shippers win. Carriers win because they can actually get paid more by hauling this kind of freight. And a great example of that, which I love this because it's a brand new feature that we just launched, and it's using a lot of what Oliver talked behind the scenes, but what it provides is so simple. So we have carriers that are using our app every day, and some of the questions are about bidding. So carriers can come on and they can bid on freight, and the shared truckload thing's new to people, right? So a lot of carriers come on and they look at the traditional stuff, like here's a shipment that's just a single shipment, and yeah, let me bid on that. I think I'd like that shipment. And we built a capability that relies on all this stuff that we've built with the solvers and the optimization technology. And Oliver touched on matching. So it looks at what the carrier bid on, and then it recommends if we actually can find a pool that contains that same shipment that the carrier bid on, but actually includes additional shipments and is a more optimal combination. And then it suggests it and says, how about this, right? And the how about this is actually more money for the carrier. So we just saw that happen, only a few days after launching this feature, which is just barely the beginnings of where we're going to take it. And we had this carrier bid on a shipment, and then get recommended for actually a pool, which added on a second shipment. They loved it, and so they said, yeah, actually I'll take that, and they get paid more to do that. But actually, Flock Freight it's more profitable for us to do that as well. So it's this great thing where when we optimize freight, it's better for our business, but it's also better for our customer. And we're reducing waste and inefficiency, so we're reducing carbon. So it's like this great thing where we don't have to have this trade-off where, oh well, if we do something that's more efficient, it's going to cost us more money, and so we don't want to do that because we want to be more profitable, right? it's this great thing where it's very motivating to be able to build this kind of technology that provides a win for everybody. So I think features
Louis,
like
I
that.
think it also gets to the importance of the data and the algorithms you guys are building. In fact, I saw a couple questions. I didn't mean to cut you off. One of the questions was how prevalent, and this may be one for Oliver or Lou, how prevalent is dirty data? For example, a load is registered as being en route from A to B, but a B, somebody manually claims the load is not there. And how do you address that in real time?
And what does it mean by manual? Somebody claims the load is not there?
Yeah.
I'm not sure I follow.
I guess it's just asking about I guess the main question is how prevalent is dirty data in your algorithms, and is there ways, I guess, to filter that out?
Yeah, I mean,
And
look,
Sarah, if you could that was by Brandon. If you want to unmute Brandon, he might be able to ask that a different way.
Yeah, go ahead.
Hang on one second. Let me see if I can.
Hello, can you hear me?
Yes.
Yeah, we can hear you.
I'll
Yes.
just unmute myself. Yeah, thanks for
Perfect.
taking the question. I think the manually part was just to say somebody calls in or somebody makes a report on the app that says, I don't see this, whereas in the system it says that your package is now at point B.
It's definitely a problem that Amazon faces.
Gotcha. Lou, do you want me to handle this one, or?
Sure.
Yeah, I mean, so that kind of like, I think the specific example you gave there was like a tracking almost type of problem. That doesn't tend to happen very much. You know, we don't. It's funny. One of our more senior product managers comes from Lyft, and if you use Uber or Lyft, you know, you've got sometimes the car will be a little bit ahead of where it actually is, and then it'll jump around to another location, right? And so that's another example of where, you know, maybe the app is telling you one thing and reality is reflecting something different. For us on the tracking side, the data doesn't turn out to be that dirty. I think maybe there are certainly areas though where data collection, you know, accurate data collection can be challenging. And I think I maybe alluded to one of those during the presentation, but you know, one of these is this idea of post-order kind of edits or modifications to a shipment. So maybe, you know, customer in all good faith attempts tried to measure out, you know, and exactly the dimensions of what they were trying to move. Then, you know, we get on the phone with them to start coordinating, you know, when pickup's going to happen and all that. And we realize, oh crap, like actually you can't, you know, pack it this way. You can't, that's not going to be how it's going to get loaded. So it's actually this other size, and now we have to adjust. And that sort of thing does happen relatively frequently, which does present sort of its own set of technical challenges on the software engineering side to keep everything sort of in sync and expiring, you know, pulling opportunities then that now might be invalid in light of new information, and resolve for it using the new information. Does that answer the question?
Yeah, you know, I was just wondering if there's any special things you do, or is it just a matter of like a manual one-offs that you would is how you address them?
Yeah, I mean, we have teams of people. This is, you know, this is not just software running on its own, right? There's a lot of exception handling and freight. That's what partly makes it very challenging. And so there's all kinds of exceptions. Things go wrong, and you have people that have to follow up and make calls and maybe track down a shipment, for example.
So
lots of operational.
Really quickly, our chairman has asked a question. How did you build your AI team, and what advice would you give to companies starting in the AI domain? And I'm sorry, Jack, we'll get back to your question in just a moment, but that's a good question, I guess, to start off with.
Sure. You want to take a shot at it, Oliver? We're still, I would say, first of all, we're still in progress.
Oh, did we lose Lou or no?
Temporarily, we lost him.
All right, Lou, I think you're breaking up here.
Oh, do I need to say that again?
Yeah, can you restate?
Yeah. Well, I said, first of all, I'd like to point out that we're still in the process of building it, and it's nascent. But what I'd say is that we've been able to do a lot with a small but mighty team. And I don't know if Oliver, if you wanted to take a stab at answering the question.
Yeah, sure. So I think as is the case with other teams in our technology department, philosophically we started with saying, okay, let's get some more senior folks in here first to kind of be leaders, or grow into leaders of the team. And the way we sort of approached that was to start by looking for folks who are maybe more generalists, who had also what I like to call like full stack machine learning experience. So could do a little bit of the deployment themselves, write good Python code, could, not necessarily were like infrastructure engineers or anything, but could work with them and speak the same language as them to, when they did have a model that was ready for deployment, get it out the door quickly and, MVP, standard MVP style, iterate, build value quickly, that kind of thing. And then, from there, we started to branch out to look for some folks with maybe more targeted specialization. So someone, for example, with pricing or economics modeling type expertise might be one type of specialty. Once we kind of had at least a couple, generalists who could be more of that jack of all trades, and it's kind of mimics, I think, what you hear on the software engineering side for startups, right? You want to get those people who can deal with, quick iteration pace and pitch in a lot of different areas first, and then, start to specialize after that. I forget, the second part of the question was there any advice that we would give to, sorry, what audience?
Companies starting in the AI domain.
Yeah, I mean, I think, so there's I guess the one thing I would say is, machine learning and data science, you have to be ready for it in some sense, right? If you don't have kind of thick enough data sets, if you don't have the right kinds of data, if you're not collecting, data kind of religiously and treating it, quote unquote, as the new oil, then you can get the brightest data scientists on your team and they won't be able to do a heck of a lot. Similarly, if you start decide, hey, I heard deep neural nets are all the rage in computer vision, and so let's get someone there. Make sure that you're set up for it. I mean, there's a lot of infrastructure, specialized infrastructure that's necessary to really have a team be maximally productive. There's some pretty interesting talks and diagrams, I think, that you can find out there that show, from a compute perspective, all these different moving pieces, in terms of like workflow management, model deployment, maintaining data cleanliness and consistency across production and research, right? All of these things are like concerns that you have to deal with that, traditional data scientists, they're really good at probability statistics, machine learning. They're not necessarily experts in Kubernetes and Docker and how to get all of these things coordinated and up and running. So, depending on what you're trying to do, if you're really trying to scale out a large team quickly and you want them to be able to move as quickly as possible, you also have to invest a lot in sort of the supporting infrastructure. I think when we spoke with some other companies, in this space, who maybe are doing data science at larger scales, they were saying, their teams are comprised primarily of machine learning infrastructure engineers and have a much smaller team of core data scientists. So, I just want to stress, don't underestimate the support cost as well.
This is Kevin. I also want to put on a pitch, especially since Brandon from Teradata is on the webinar. Tech San Diego does host a data science roundtable. So if you're not on that roundtable, send me an email, kevin.carroll@techsd.org, or Sarah, and we'll make sure it's taken care of. We're bumping up against 11th. I have 11:33. I think we had one. I think we're going to be able to get to one last question. Hopefully it'll be quick. Somebody had asked, what machine learning framework are you using?
Okay, but I am not sure by
Yeah, that can mean a lot of things.
So in terms of our software stack, maybe that's what they're asking about. We use Kubeflow. It's still pretty new technology, but more legacy systems might use Airflow or something like that. So Kubernetes native, workflow management with built-in kind of support for notebook servers and things like that, and the accompanying technologies around that. So Kserve to deploy models as microservices with built-in support for feature drift monitoring and things like that, to help kind of smooth and expedite that the process of deploying and scaling up a model. If the question was more about what particular modeling approaches do we use, are we using deep neural nets, are we using gradient boosted trees, unfortunately I don't think we can get into that level of detail here, so I'll kind of leave it at that.
Sounds good. So once again, Oliver and Lou, for you guys taking an hour and a half out of your day, I know how busy you guys are. I want to thank both of you for taking so much time out of your schedule to address AI and machine learning trends. We learned a lot. A lot of us now on a call know a little bit more about freight and about how you guys handle it. So again, I want to give one more big thank you. Thank you to our sponsor, Cooley, for sponsoring the AI and machine learning trends. TechSD.org if you want to know more about the organization which I represent. Again, we have a pretty vibrant data science program, and we have a couple different program series. Sarah, anything I missed?
Nope. This replay will be available on Tech San Diego's YouTube channel starting tomorrow. So feel free to go ahead and seek out Tech San Diego's YouTube channel if you'd like to watch this or share it with your friends.
All right, we'll end this AI machine learning trends, and we'll see you guys at the next one. Thank you very much.
Thank you.
Thanks, everyone.
Bye-bye.
Thank you.